All right. So today we're going to talk about the relationship between disposable income or GDP later on actually, and spending. First off, we need to make the assumption, which we should all know, not because we read it in a book, but because we just know logically that people don't spend all the money they make. We save some. And if we didn't, then this would be very easy because GDP would be, infinite, with the only limitation being how many times you can get and spend a dollar in a given year to count for that year's GDP. So, because when we spend more than we make as a group, not an individual, or when we don't spend everything we make, that has an effect on the economy that'll either create inflation, it cause the economy to grow, or a recession. And I'll show you. So let's say, for example, and what I'm about to do is what's called the consumption schedule, and I'm going to do the data table first, and then we can look at the graph later. So let's say that we're just going to call it DI for disposable income, or it's going to be income. Later, actually, this is going to be GDP. So we have disposable income and we have consumption. All right, so we'll start here, real simple, and actually not accurate, but we'll get to that later. Let's say that a society, because remember, we're talking about a society or an economy, not an individual, because we can't really predict what a person might do with the next dollar they earn. If you give someone $10, what are they likely to do with it? But we can predict in the aggregate with society behavior patterns. So like right now, in America, we spend about I think 94% of what we earn. So 94 cents out of every dollar we spend. And so while that might not apply to a person, we can use that pretty reliably for an entire population. So let's say that this population gets $10. Okay. And let's say of that $10, they're saving 20 or $2, 20%. So that's going to look like this, right? So we go from $0 to $10. Our total spending goes from 10 to 8. And I'll go 20, 16, 30, 24, and 40, 32. All right. So you get the idea, right? And why this is a problem for any of these is this creates what's called a recessionary gap. See, because this income that we get is based on the fact that we produce things. Yeah. If we produce, say, $20 worth of stuff, but we're only spending 16, then that's $4 worth of stuff that is getting produced. Somebody got paid to make, but it doesn't get bought. So then what's going to happen is if you're making stuff and it's not getting bought, it's not going to get made anymore. Either a business or an individual will reduce their production. And what's going to happen is, so say we're at this 20 and 16 spot, we realize we have 4 leftover dollars worth of goods. The next year or the next chance we get, we're actually going to reduce the amount we produce because we didn't sell it all. So it didn't all get bought. So we're going to reduce the amount we produce down to, let's say, 10, right? But when we do that, we also reduce our income. And if we're still only saving a portion and spending a portion, then that's still not going to align. And we're going to have, say, like this, for example. It could be somewhere in between, right? It could be, it would be $15 and let's see, this would be 12, right? So 15 and 12 would be right here. Either way, no matter what we do, no matter how much we reduce our production, we're also going to reduce our spending, so that we're never going to achieve that equilibrium. We're never going to actually be able to purchase everything we're making because we're saving. And think about it with like 2 people in an economy. If Bill makes stuff and sells it to John, then Bill gets paid, right? But then if Bill saves a portion of that money, say it was $10, right? If he only then buys $8 worth of stuff from John, John only has $8 to buy stuff from Bill the next time. And Bill is only going to produce $8 worth of stuff. But he's going to save 20% of that. And it's just, you get the idea. Anyway, fortunately, this is not actually the way it works. It is, but these are not accurate numbers, like I said before. It turns out that we are willing and able to what's called dissave, which is spend more than we make. At low levels of income, say zero, we'll take zero for an example, our spending isn't zero. Our spending is some other number because there's things we have to buy no matter what. Food, clothing, rent. So if our income as a society is zero, say the United States just took a year off from producing, everybody took a year off, we'd still buy stuff. We would end up having to buy stuff that was left over from previous years or from other nations or whatever, but we're still going to buy stuff. So at zero DI, consumption is more like this. Now, what I described before about when we had the disposable income at 20 and the spending of 16, how this gap here, when this number is smaller, the consumption is smaller than income, that would trigger a reduction in production, which would be a reduction in income. The same is true in reverse. In this circumstance, when we're attempting to buy things, but we're not making anything, that is going to encourage businesses, producers, whatever, to increase their production. And to do that, they obviously, production means income. So say like they do that, right? And then say then the people get paid. So people had an income of zero, now people have an income of 10. When we get $10, we're not going to spend all 10. We'll use the same ratios as we used in the last one. What's going to happen here? We're going to spend 8 out of this $10 that we get. So our total spending is going to go from 10 to 18. And then that is still what we call inflationary. Businesses are going to be encouraged to produce more. Individuals are going to produce more because people are trying to buy it. And as a producer whose income relies on producing things, you're going to produce more. So you produce more. You hire workers, right? Like whatever, to make more. And people will get an additional $10 of income as a result of that from your efforts in production. But they're not going to spend all 10. They're only going to spend 8 of that. So add 8 here. I'll go all the way down. All right. So what this is showing is that whenever total spending exceeds income, you have what's called an inflationary gap, which encourages more production and more income, and it'll keep going up and up and up and up because we'll keep pushing on it until we get to some income level, which is right here, where total spending equals total income. That is sustainable. John buys $10 worth of stuff from Bill. John gets $10. Bill gets $10. Bill buys $10 worth of stuff from John. John gets $10. John buys $10 stuff. It just keeps going over and over. It is what we call equilibrium or the break-even point. And if we were to keep going, you can see that now this is what we call recessionary. Again, like this, at some point, our savings is increasing to the point where we are now overproducing. And then this will actually pull it like here. We'd reduce production and we get back to here. Okay, so this is the magic, what we call break even, but I don't want you to worry about that term. What I want you to start thinking of this is equilibrium GDP, because GDP is total income in an economy. It's also total spending. Right now we have a simplistic model where the only income we're talking about is individuals' income and the only spending we're talking about is individual spending. But other entities generate income and other entities can produce or spend in an economy. So like this is actually going to be GDP and this will be C plus I plus G plus XN, and then we'll add it all up and whatever. Don't get scared. So that's what this schedule shows. It shows the relationship between income and spending. And graphically speaking, again, where we have consumption, disposable income, this would be what's called the 45-degree line. This is essentially income, right? Like this is what your income is. And then this other line, I'll use a different color. This other line is going to be representative of what our actual spending is. Because our spending doesn't, when our income goes up, our spending goes up too, but only by a fraction, 0.9, 0.8, whatever. So this is a graphical representation of the table I just showed you. And again, this is not actually the truth. It's just for understanding's sake. The actual truth is that at zero disposable income, consumption is, not zero. And then when we plot out this line, you could see that at some point we have equilibrium. Going back to the table, if you want to rewind the video and look at the numbers, this would be the $50 mark. So 50 and 50. Our income was 50 and our total spending was 50, and that's sustainable. This would be like, 60 and 52, and then this would be, all the numbers before that. So that's that. That's all that graph is. It's going to get more complicated later, but for now, that's what it is. So when we look at this, we'll use different numbers. 0, we'll call it 70, 100, and then 160, and so on and so forth. Math, Tony, math. 250. All right. The important things to remember is that the behavior pattern, okay, the amount that spending increases whenever you increase income is constant. In this instance, for every $100 that we go here, we're spending 90 of it. So this is going to be, 400, 430, 500, 520. It's 520, 600, 610, 700. And 700. And let me double check my math. Let's see. MPC of 0.9, MPS of 0.1, multiplier of 10, 70 times 10 is 700. Yep, you're right. Okay. So there we go. That would be the break-even point. This behavior pattern, okay, how much of each dollar that we might get, that we spend, is what's called MPC, or marginal propensity to consume. The amount we save is MPS, or marginal propensity to save. In that example I just gave you, we were spending 90 out of every 100, which is also 9 out of every 10, or 90 cents out of every dollar. It doesn't matter. It's a ratio. In this instance, is 0.9. The MPS, then, we were saving 10 out of every $100 we got, or 1 out of every 10, or 10 cents out of it doesn't matter. It's 0.1. MPC plus MPS must equal 1, because that's the only things you can do with a dollar, spend or save. So that's what those are. And this is really important because we'll be able to know, given any data, if we have one of these, just one, or even a data table like all we need is that. We know that for every $100 we get, we're spending 75. So that means we are spending 75, that's the MPS, of every dollar, and we're saving 25. Okay? It's worth noting for this class, for the AP test, for whatever, the MPSs and MPCs you're going to see most frequently are going to be 0.9 and 0.1, 0.8, 0.2, 0.75, and 0.25, and then 0.5, maybe, which would make this 0.5. And there's a reason for that. It has to do with the math is easy, because these turn into something you're going to learn later called the multiplier. Multipliers of 10, 5, 4, and 2, which are easy math. If you have an MPS of 0.95 and an MPC of 0.95, an MPS of 0.05, that's a multiplier of 20, and that gets weird. Or say, for example, an MPC of 0.66, that makes the MPS 0.33, 3, 3, 3, 3, 3, whatever. That is a multiplier of 3, and fine. But every other number gets just weird and hard to work with. So that's that. There's actually going to be more parts of this particular series on this chapter, but this is at 15 minutes, so I'm going to cut it here. Expect more videos to come.